To find the measure of angle t, we have to recognize that it's something called an inscribed angle. An inscribed angle is an angle whose vertex lies right on the circle. And the way this works is, to find the angle, we take half the arc that it intercepts. Another way to think of this is if we know the angle, we can double it to find the arc. So you're either dividing by 2 or multiplying by 2, and what I like to keep in mind is that no matter what, the arc is always the bigger number. So in this case, to find the measure of angle t, the inscribed angle, I take half of the arc it intercepts. Since the arc it intercepts is 48 degrees, this means the measure of angle t is 24 degrees. Okay, works just like that. Next up, they asked me to find the measure of an arc, and this time it's arc QR. So if I take a look, that's this arc over here. I'll trace it out in orange. Now, there's no inscribed angle that intercepts that, but if I'm clever, I could take a look at this angle right here, angle R. Angle R is an inscribed angle. So, since I know that angle is 50 degrees, I can double it to find the arc. Remember, the arc's always the bigger of the two numbers, if you forget whether you're supposed to multiply or divide by 2. So this arc QT is 100 degrees. Now, you may be thinking, well, that's not the arc I wanted to find, and it's not, but we're closer to find it. Because if I take a look, again, I have to be clever about this, this red arc all the way from T to R is a semicircle. It's 180 degrees, because I can see that I have a diameter. So, if this arc over here is 100, this one must be 80, the one in question. So we can take a look at a couple basic examples down here asking us to find the measure of the red arc or angle. Once again, as long as we have an inscribed angle, an angle whose vertex is on the circle, it's half the arc it intercepts. So the arc this intercepts is 90 degrees, meaning angle G, or the angle I'm looking at, needs to be 45 degrees. The arc will always be the bigger of the two numbers. Next up, we're given the inscribed angle. It's 38 degrees. The vertex is right on the circle. So to find the arc, I double the angle. Doubling 38 degrees gets me 76 degrees for the arc out here. And last up on this screen, this is kind of an interesting problem. Take a look at the inscribed angle they give us right there. It's 72 degrees, and they ask us to find the other angle. Well, I call these the spotlight problems because I kind of imagine this as a spotlight. And what I notice is that let me switch colors actually, both angles kind of spotlight or intersect the same arc. And so I know that if I have the inscribed angle of 72, I can double it to find this arc out here. That makes this a 144 degree arc. Well, since angle X spotlights that same angle, I can again double it, or divide it by 2, to go back in and find out that this is 72 degrees. Or a shortcut for these is, you'll notice, both of those are going to be the same. As long as both things spotlight the same arc, they're going to be the same angle. And last up, we'll take a look at these two examples, which again ask us to use inscribed angles. However, we have to be a little bit creative with our thinking again. I'm asked to find the measure of angle G, so I'll go ahead and trace that out so I can see it a little bit better. So there's angle G. I can see it is an inscribed angle. However, the arc it intercepts, I don't know. However, I can find it. Since I know that in a full circle I've got 360 degrees, if I subtract off the 120 and subtract off the 70, I'm left with an arc of 170 degrees. To find the angle then, I divide by 2. Remember, the arc is always the bigger number. Half of 170 gets me an angle of 85 degrees. So G is an 85 degree angle. And last but not least, I want to find the measure of an arc over here, arc VU. So I'll kind of trace that out so I can see what I'm looking at. To help me find this, let's take a look at what we're given. I've got an inscribed angle right there. So since I've got an inscribed angle, I'll double it to find the arc it intercepts. So this arc out here has to be 60 degrees, which is not the angle I want to find, but as you saw in that previous example on the previous screen, I've got a semicircle. So I know that halfway around this is going to be 180 degrees. Since the arc that I just found is 60, that means the one I want to know, arc VU, must be 120 degrees.